have another conversation that really borders on our health. Now, there is something called Streptococcus pneumoniae. I hope I got it right. Prof would put it right for us. Now, it remains one of the leading bacterial causes of pneumonia, meningitis, bloodstream infections, and ear infections globally, particularly among children under 5 years older, adult, and immunocompromised individuals. I mean, these are scientific words, right? I'll leave it to Prof to break it down for us. But globally, we understand an estimated 14.5 million severe pneumococcal disease episodes occur annually among children under 5 years, resulting in approximately 500,000 deaths, most occurring in low and middle income countries like ours, Ghana. That's why it's important that we talk about this. So today I have in studio Professor Nicholas T.K.D. Dayie. Is that right?
Dayie.
Dayie? Okay. And Prof is a Professor of Medical Microbiology at the University of Ghana Medical School. Prof, good morning to you.
Good morning.
Yeah, you're going to have your inaugural lecture, right?
I had it.
Oh, you have it, and this was the topic?
No.
Hey, this wasn't?
No.
But why is this an important subject we need to talk about?
Well, this is very important, as you've rightly put it, that before I start, I would like to express my gratitude to the university authorities for making this arrangement for me to interact with the public. Indeed, this is a very important topic because, as you've rightly said, about 14.5 million episodes of pneumococcal disease were reported globally annually. And also 500,000 children under 5 died as a result of pneumococcal infections annually. So this is a great issue, and it has implications for us in Ghana.
Okay, so the theme you spoke on during your inaugural was when microbes speak and data appear inconsistent, are we witnessing falsehood or truth?
Yes.
Why? There are differences in terms of what you see under the microbes and what the data says?
Yes,
okay.
Sometimes.
Okay.
Sometimes two inconsistencies reveal what I would call insight. That is important for the scientists to help us plan. And sometimes also the inconsistencies as a result of what I would call methodological weaknesses in our diagnostic capacity. And thirdly, there is something we also called certain genes that the organism possess. They are not revealed until certain laboratory test conditions are set. So these three things could be at play anytime you're talking about data. And data is not truth. Data production must be engineered to produce truth.
Okay.
And as clinicians, we make use of accurate data to treat patients.
Okay. So in terms of this Streptococcus pneumoniae we're talking about here, the data we have says 40 million people, so 40 million severe pneumococcal disease episodes occur annually.
Yes.
Out of that, children under 5,
yes.
500,000 die.
Yes.
That's truth.
That's truth.
Okay. So how does it come about?
Okay, for the public to benefit from this discussion, permit me to give you a little bit of background. In our environment, there are two types of living things. We have those that are big enough for the naked eye to see, and we call them macroorganisms. And then there are those that are too small for the naked eye to see, except with the aid of a microscope, we call them microbes or microorganisms. The field of science that deals with microbes, we call it microbiology. And the scientists that handles microbes, we call them microbiologists. Now, in the field of microbiology, we have bacteriology, which is the study of bacteria. We have viruses, virology, which is a study of viruses, parasitology, which is the study of parasites, and mycology, which is the study of fungi. I am a bacteriologist.
Okay.
And in bacteriology, we deal with what we call commensals and pathogens. Commensals are normal flora that live with our cells. They help us to train our immune system. They help us in the production of vitamins. They help us in digestion and metabolism. And they also help us in case you pretend that you are dead. They help reduce your body to dust. Those are commensals. But the pathogens are microbes that cause disease. Now, the Streptococcus pneumoniae is a normal flora or a commensal that lives at the back of the throat or at the back of the nose. It lives there as a normal flora.
Okay.
And about 70 to 80% within a population from the age of 0 to 5 carry these organisms. Okay? Now, they are there.
So when we grow, so as you and I,
yes,
are they there or they are not?
They were there when we were younger.
But they are.
But as you grow older, by the age of 5, the courage decreases until you are 65 years old, and they come back.
Hey, okay.
Their job is to protect you from other virulent microorganisms that are very lethal. So that is why from 0 to 5, your immune system is not well developed, so they are there to train you. So by the age of 5, you would have a maturing immune system that can handle issues. So by that time, courage decreases. So we say that courage increases with a decrease in age, or courage decreases with an increase in age. So that's about the organism. Now, as they stay in the nasopharynx, or the back of the throat or the nose, certain conditions such as immunodeficiency, that is, if your immune system becomes weak as a result of malnutrition or HIV/AIDS, or you are on cancer therapy that reduces your immune system, this organism has opportunity to move from a normal flora to become a pathogen. So initially, they are normal flora, help us protecting us, but they can also become pathogen. How do they become pathogen? They move from the nasopharynx into the lungs. And the lungs are supposed to use for gaseous exchange. We breathe in oxygen, and then we breathe out carbon dioxide. So the organ that enables you to be alive in terms of breathing is the lung. And these organisms, once they get into the lung, they have a thick capsule, so the body is not able to destroy them. So in the lung, instead of the lungs, the tiny sacs maintaining oxygen or removing carbon dioxide from the body, they are rather filled with fluids. So it leads to incapacitation of your lungs, which can result in death. Now, from the lungs, they can move into the blood, infecting your blood. And from the blood, they can enter the CSF, leading to meningitis. So Streptococcus pneumoniae causes 2 types of diseases. We have the invasive pneumococcal disease, and then we have non-invasive pneumococcal disease.
Common names for those.
The invasive, that is bacteria entering into sterile sites of the body.
No, I thought there were common names for those diseases. The 2 diseases you've mentioned.
Pneumonia.
Okay.
That is inability for your lungs to breathe.
Yeah.
Then meningitis.
Okay.
That is inflammation of the meninges, that is the membrane that is surrounding your brain.
Okay.
So those are the common names.
Okay. But so once we now know that when they get into the lungs, that's where they're able to do the things we're talking about. Is there any preventive measure?
Yes.
Okay.
We have a preventive measure and we have a curative measure.
Okay.
The preventive measure is the administration of vaccines early in life. In Ghana, the vaccine has been introduced in May 2012 for children under 2 years.
Okay.
It begins from 6 weeks and 4 weeks apart, 3 doses. So 6 weeks, 10 weeks, and 14 weeks. And then you are done.
Okay.
And that is supposed to protect you from invasive pneumococcal disease, as well as any other disease. And within the vaccine, I want to put it this way, the organism has got what we call a capsule, that's a coat. They keep changing the coat from time to time to evade your immune system. The essence of vaccination is a rehearsal. So because vaccines are preparations that are given to hosts or individuals in order to prepare you or to develop your immune system to fight against the real pathogen when they do come. So based on the coats that these organisms wear, there are over 100 different coats that they wear. So based on the coat, we've realized that you can produce vaccines against those that are most dangerous. We call the different subtypes of the pneumococci, we call them serotypes. Okay. And of the over 100 serotypes that are in existence, just a few of them, about 13 of them or 20 of them that actually are involved in over 70 to 80% of the pneumococcal diseases. It is those that the vaccines are made against. And you can't just go for any other vaccine, like vaccine made in the United States or vaccine made in India or elsewhere. You have to make vaccines that agree with the serotypes that are circulating in Ghana, because geographical location determines the serotypes that are in circulation.
And the study on which you did your inaugural lecture was based on this?
No, it wasn't based.
No, because I read that the study demonstrated concerning levels of antimicrobial resistance among invasive pneumococcal isolate. Is that something you have done in the past?
Yes, there's a current study we've done.
Okay.
And this study looked at pneumococcal serotypes in Ghana in invasive isolates. Let me give you a little background. In 2016, we conducted a carriage study. First, before you get the disease, pneumococcal disease, you must first carry the organism in the nasopharynx. Without carriage, there can never be invasive pneumococcal disease, because it's from the nasopharynx that the organism moves into the lungs, into the blood, and into the meninges to cause the 3 types of diseases I mentioned. Now, the study we did in 2016 and published in 2019 revealed that after the introduction of the vaccine, there are emerging non-vaccine serotypes. That means the serotypes are not included in the vaccine. So if they are not included in the vaccine and they're in the population, they can cause disease that the vaccine cannot protect you against. We observed that serotype 23B, which is not in the vaccine, was circulating in Ghana. Well, courage, we continue to do surveillance. And in 2026, our current data shows that this serotype 23B that we observed in 2016 and published 2019 has actually caused serious invasive disease. And we found it to be the second dominant serotype circulating in Ghana. It is not in our current vaccine. And the new vaccine that has also been made, called the PCV20, is also not in it. So if Ghana decides to move from PCV13, which we currently have, we are giving out, to maybe the latest vaccine globally, which is PCV20, that also does not contain this serotype 23B that is circulating in Ghana.
So we are administering vaccines that are not dealing with a major issue in Ghana.
Not necessarily so, but let me explain.
Okay.
When you give vaccines, it creates a vaccine pressure. Within the vaccine, you have certain serotypes within it. Those serotypes may be wiped out. Once they are no longer occupying the niche, other serotypes, remember I said we have over 100, replace those ones. So it's a phenomenon called serotype replacement.
Yes.
And sometimes we also have what we call capsular switching. The organism change their coat. So capsular switching and serotype replacement are major means of outwitting the vaccines that we have. Now, over time, the vaccine 2012, over time, we've realized that there is an emerging serotype which is not in the vaccine. So that knowledge is supposed to guide either the Vaccine Institute or the policymakers to now include the current pneumococcal serotype that is not in the vaccine.
Yes, but this is what you found in 2016 and published in 2019. The serotype 23B.
Yes, in courage.
Yes.
But now
you found that it was there.
Yes.
2016 to today, you found that has even led to some invasive.
For the first time, it is for the first time we've noticed that the non-vaccine serotype has caused invasive disease.
Yes.
And is dominant now. So that information is supposed to help the policymakers either. The current vaccine can't deal with that, but we have the curative option, which is the administration of antibiotics. So we cannot prevent the disease that 23B will cause by vaccination, but we can treat the infections that they cause. Unfortunately, we have rising antibiotic resistance to this particular pathogen.
The serotype 23B.
We've realized that 34% of the drug of choice, The drug of choice is third-generation cephalosporin, such as the fluticasone, documented in our standard treatment guideline. We've realized that in this current study, 2026 published data, we realized that 34% of the isolates are resistant to this drug, which is the main drug to be used in invasive pneumococcal disease.
When you say 34%, am I right to assume that then a certain percentage is not resistant to the medicine?
A certain percentage of this.
Okay. But if that's the case, why is a certain percentage of the microbial population not resistant to it, but 30-something% is resistant? Is there a difference in their DNA makeup? That's why. What is really causing?
There are different strains. There are different genotypes, and bacteria acquire resistant genes in order to become resistant. Even though that 34%, in 2013, when we did a study, only one organism was resistant. But 2013 now to 2016, it is increased, and 2026, it has now increased to 34%. And we've also seen 42% of all the isolates demonstrating multi-drug resistance. That means that they are resistant to 2 or 3 more classes of antibiotics. That reduces the doctor's capacity to select the best drug to treat infections. So surveillance is important, constantly surveilling to find out which serotypes are not in the vaccine that are in circulation in Ghana, and what is the level of antibiotic resistance that they demonstrate. This is very important.
The reason I was curious earlier was that even in 2016, you found serotype 23B to not be affected by the vaccine we are administering in Ghana. I believe that research is supposed to inform policy and the decisions we take. We have not been able to devise vaccines that handle that serotype. That even 2026, the vaccines we have, and you said something that even got me scared, that the higher one that has been developed still will not be able to tackle the serotype 23B.
Yes.
What are we then doing?
So this information is so important for the policymakers. Not to spend money going for the newer vaccine, because it will not help solve our problem. What is important is let's resource our vaccine institute established so that they will have the capacity to produce the vaccine that is needed to cover the serotypes that are circulating in Ghana. So the alternative here means that, okay, you can't prevent, but you can treat.
So you decide whether you want to prevent or you want to treat. And even the treatment, that's another challenge there. Exactly. So what is our best way out of this?
In a short run, is antimicrobial chemotherapy. That antibiotic therapy is the measure for 23B if they cause disease.
When you mention chemotherapy, my mind goes to
antibiotic therapy.
Okay. So we just have to give antibiotics to
when the person is properly diagnosed, then antibiotics can be used to treat the infection that they cause. In the long run, we need to resource our vaccine institute so that they are able to produce vaccines locally that will be able to cater for the serotypes that are in circulation.
But Prof, you mentioned that 23%, and in some areas 44%, 33%, and in some areas 44% are showing resistance to drug. You mentioned, I think, about 1, 2, 3 drugs. The bacterial are showing resistance to them. So even the immediate term that we want to treat, there's a challenge there.
Yes.
Because some of these bacteria are resisting the impact of the medications we give them. So how we delayed from 2016 to 2026, we couldn't find a solution to getting vaccines that will tackle this 23B serotype. I mean, I'm really...
Takes time. Research takes time, and the information, it takes time also for the policymakers to utilize it, because a lot of people come into play here. Remember, let me put it this way.
Unfortunately, Prof, you're not a policymaker, but when I see the number, 12, the number you said, 14 million.
Yes.
Severe pneumococcal disease episodes occur annually among children under 5, resulting in 500,000 deaths This is global figures,
That's
right?
Global figures.
Yes. So as any policymaker should take this figure and say, once we are not able, our vaccine is not tackling serotype 23B, and this has been in existence for 10 years, we should probably within the 10 years have found a solution to it.
I should say that they are thinking about it. They are thinking about it. But let me let you know that the vaccine is not a failure.
Okay.
The vaccine has really, Ghana has really done well. The vaccine coverage is about 97%.
Okay.
That is great news.
Okay.
And the vaccine since 2012 to 2025 has averted 3.7 million episodes of pneumococcal disease. Secondly, it has also averted the death of 40,000 children under 5 and also averted 160,000 hospitalization.
Okay.
So Ghana is really, really doing well.
Okay.
We are high performance when it comes to pneumococcal vaccine utilization.
Okay.
But the kicker is this: there are emerging serotypes that are not found in the vaccine. So sustained...
That's apart from the serotype 23B,
yes,
there are emerging ones.
There are emerging ones.
Hey.
There are emerging ones. But the real issue in terms of the curative aspect that bothers me is antibiotic resistance.
So how do we solve that?
This is a huge issue, and it's called the silent pandemic. In 2019 alone, 1.27 million people died globally due to bacterial infections that demonstrate antibiotic resistance. And the same 2019 alone, about 5 million deaths were associated with infections caused by antibiotic-resistant bacteria. And by 2050, it's projected, if we move on this trajectory, 10 million people will lose their lives every year due to infections caused by antibiotic-resistant organisms. And Ghana is ranked 35th out of 204 as a country where antibiotic-resistant deaths are noted.
Hey, 35 out of 234.
Yes, that's our place. And this is caused by one of the organisms involved in the causation of death in Ghana is Streptococcus pneumoniae. It's one of them. Our huge problem is with diagnostics. We have a huge problem with diagnostics. You know, surveillance runs on diagnostics. If you don't have well-equipped laboratories, what happens is that your surveillance data will be inconsistent with what the microbes are saying. And surveillance data do a lot of things. One, it informs national policy on antimicrobial resistance. Surveillance informs antibiotic treatment guidelines, review of them. Surveillance help us also to improve antibiotic stewardship program as well as allocation of scarce resources.
Okay.
So if the diagnostics are not robust, it means surveillance data will not be robust enough, and it can lead to dangerous decisions when utilized. So it's important for government to help us resource our laboratories, resource the laboratories, make available reagents, consumables, training for laboratory workers. So
in 10 seconds, Prof, I wanted to speak to him directly. Watch into your mic and speak to government.
Your Excellency, we know that you are doing a lot for Ghana. We believe in you, and we know you can do more. The problem we have today in Ghana with respect with diagnostics is that we don't have well-equipped laboratories. We need your assistance. We don't want our health to be in the pocket of donors. We want local resources to be able to sustain our health, and we know you'll be able to do that for us.
Prof, I'm grateful to you. Thank you for coming. This has been an eye-opener. Professor Nicholas T.K.D, is it T.K.D? Dayie is a professor of medical microbiology at the University of Ghana Medical School and a consultant bacteriologist with research interest in antimicrobial resistance. He recently delivered his inaugural lecture at the University of Ghana on the theme, "When Microbes Speak and Data Appear Inconsistent, Are We Witnessing Falsehood or Truth?" Prof, all the best to you.
Thank you.
But I'd love to have you again.
Yes,
on the
I'd
show.
love to come here.
All right.
Thank you.
Well, we'll take a break here. We have E-Corner for you. No